It gives me great pleasure to welcome everyone to this year's Craig Johnson Lecture in Excellence in Landscape Architecture. Professor Johnson, who is now an emeritus professor in the department, worked for over 40 years as a professor of landscape architecture and environmental planning. He was critical in establishing the tone and direction for our department. As a researcher, Craig focused on environmental planning and reclamation. He wrote numerous publications on the subject, and he received a Wildlife Society's Outstanding Book Award for conservation corridor planning at the landscape level, management for wildlife habitat. Craig also was passionate about teaching and was awarded over 17 different teaching awards, including ASLA's highest, the Jot Carpenter Teaching Medal. Craig Johnson's philosophy is, it is best to teach by example, stay current, get in and out of the field, and work with professionals. Bring back ideas into the classroom. Successful teaching is a combination of applied research, staying current, using solid people skills, and being passionate about your subject. It is in this context that it gives me great honor and pleasure to welcome Professor Kristina Hill. Kristina was my advisor at UC Berkeley, and I learned so much from her over the years there. And she really does passionately embody very much of what Craig Johnson was all about. And so I think it's very apropos that she's here today with us as the Craig Johnson speaker. Professor Hill is an associate professor at the University of California, Berkeley. Professor Hill studies urban ecology and hydrology in relationship to physical design and social justice issues. Her primary area of work is in adapting urban districts and shore zones to new challenges associated with climate change. Professor Hill received her PhD from Harvard and was a member of the faculty at Massachusetts Institute of Technology, the University of Washington in Seattle, and the University of Virginia before coming to California. So it's with great pleasure that I have Kristina Hill here today. And we're actually going to be doing something a little bit different. We're going to be doing more of a dialogue. So over the course of the next 45 minutes, I'm going to be asking Kristina a series of questions, and she'll be able to speak to us all about her work and her research. Welcome, Kristina.
Thanks. I see that Andrew has his hand up, and you know, what kind of good teacher would go ahead without checking to make sure there isn't a question? The hand is gone. Was it accidental? Andrew Winterton, hand up, but you're good. Okay.
Yes, sorry, it was an accident.
Okay. There are lots of Zoom accidents. I think we've all figured that out over the last month or so. So thanks, Daniela, for having me. It's a pleasure to get a chance to talk to people in your world out at Utah State. So thank you.
Well, thank you for being with us. And my first question is if you can please tell us about yourself. Where do you come from? What is your academic training? What's your professional history?
Just super briefly, I first had a degree in geology and then thought, you know, the jobs that were available when I graduated in geology were mostly on oil rigs. I didn't want to work on an oil rig. So I decided to go for graduate training and thought that landscape architecture might be an applied version of geology. I also had gone to art school for a year and I thought, oh, landscape architecture will be this great mix of science and art. And it is and it isn't. That's what I learned. But then I went to teach at Iowa State and as you said, went to MIT, and I've kind of used having an academic career as a chance to move around and see what's happening in different parts of the country and different parts of the world. I've worked in Europe and South America, recently have consulted in New Zealand, and did a brief stint as the head of a public agency in Seattle, totally by accident. I became the head of this public agency. It was a transportation agency because two other people resigned over one weekend, and then boom, it was me. And it was kind of like becoming the captain of the Titanic after the iceberg. So it was a crisis experience and not to be recommended, but it's taught me a lot about money and politics, in addition to thinking about design and planning.
Great. Well, I know you've had a diverse background. And my next question is, what is your current area of work? Do you focus on environmental planning, landscape architecture, design? How do you see those fields as distinct or coming together?
Yeah, that's been a big debate while I've been in the field for the last 30 years. When people were talking about ecology versus art, that was a big distraction for a while. I don't understand why there'd be any reason not to bring both into what we do. I've never understood why anybody would oppose them. Maybe I'll share my screen and just show a couple pictures to talk a little bit about current work.
Great.
So this is how I see the area that I work in. It's at the intersection of talking to policymakers. I get to share a lot of their experiences, having been the head of a public agency. So I'm usually pretty good at talking to policymakers about what their pressures are and what their context is. I work in physical planning mostly, giving form to things and deciding what might be built somewhere as opposed to something else. And then I work in design at the site scale. I work mostly on form and function relationships, and then what kinds of cultural meanings people might take from different form and function relationships. I'm really interested in how adaptation to climate change might give us a chance to inspire people with design, make them feel braver. You know, there's a lot of design that has dealt with how to inspire courage in people. A lot of memorial design does that. And then I'd like to find out how design can help us think about shared resources, to see ourselves as part of a community sharing resources for adaptation, not just one family at a time. And then I'd like to see design help us expand our compassion for people who aren't like ourselves and for non-human species. Because so much is going to be changing. There's no way to keep everything we have now. We need to figure out how to move forward together instead of keep things the way they are. And I know all this because my original training is in science. So I'm interested in how we can really make things change in the way people plan and design and live because of my science training that tells me things are changing. So that's in a nutshell how I think about where my work sits. And I mostly work in the physical planning and design part of that, sometimes in science. But I prefer for other people to do the science and I get to apply it. I only do it when no one else will do it for whatever reason. I wanted to talk for a second about landscape because that's my passion. That's what attracts me to all of this. And this is an actual aerial photo of a region in Kyrgyzstan, northwest of China. And it looks like a textile or a fabric. To me, it's a great example of how landscape can be boiled down to a two-dimensional flat surface. It's an illusion. It's not the reality. The reality is this is topography and water and roads and soil eroding. But what we see when we look at a photograph like this or a lot of our plans, it's like bark or some kind of texture. It's fascinating aesthetically, but it's actually not what I'm interested in. What I'm interested in is this version of Kyrgyzstan, where you can see structure, you can see ridges, you can see a plain, you can see a shoreline. I'm interested in this mosaic and how it works. How does water move? How do animals move? How do people move? How is the environment itself changing with climate change? So that's what really excites me, is to see the armature, the mosaic of a landscape, and especially the underground, which I think is the special sauce of landscape architecture. That if we understand the underground, and you can tell I'm a geologist because all geologists think that the underground is the root of all knowledge. I think that if we understand something about the underground, we'll be able to understand better what the flows are in the world at different scales and how we can surf those flows, learn to surf them as we adapt. And whether it's human structures, human armatures, or whether it's natural systems, same question. This is a different scale. This is how currents work on the earth and the ocean. I work a lot now on sea level rise. So I'm interested in how currents will affect the way that seas rise in different parts of the world. It won't all be the same. And it depends on these currents and how they change. So this kind of flow and interaction and armature at the global scale and in the water as well as on the land. What's so great about this idea of flows and mosaics and armatures is that it's true at any scale, that you can use this kind of lens as a way to see what's happening in the world. And then I'm interested in culture. This is an example of how climate and culture have been related historically. During the so-called Little Ice Age, when Europe got cold in the last millennium, there was a phase where people were so upset, so freaked out, so unable to manage how their lives were in relation to climate because crops wouldn't grow, rivers were freezing that didn't used to freeze. They started to take it out on each other. And that kind of human negative tendency to turn on each other is what I want to figure out how to avoid as we go into this new adaptation to a warmer climate with lots of other problems for excess heat and droughts and fire like we've seen here in California. So this has real cultural implications when the environment changes. Sorry, I'm just going to skip ahead to this one because I wanted to focus on the way that underground, the world of the underground is an interesting place in urban areas as well as in rural areas, as well as in terms of topography. So this is a map of New York and it shows subway tunnels and water tunnels and drainage tunnels that are all part of that city. And that's something that's crucial to understand as we look at cities adapting to climate change as water rises below us. I think I just have a couple quick slides and then I'm gonna. So I wanna leave you with this thought of there's form, there's armature and landform and mosaic, and then there's all the ways that animals interact with that form. For example, hawks following a topographic ridge in a migration pattern. We live in this crazy mixed world of all these different things interacting with each other. And that's what I mostly work on is that system. This last image is just the one I'll close on for this opening set of slides. And I love this old atlas image because it shows a cross section that goes underground as well as a big bird's eye view of a regional scale. And I think this is really what environmental planning needs to bring to design, is this bigger view of the larger scale armatures that we can then come down to the ground with and talk about, okay, there's sea level in the 1950s or 60s when this image was made. As that changes, how will that affect everything on the ground? What do we need to design to be ready to surf that change? So that's kind of an introductory volley about what it is that I do.
Great. I love the variety of scales and bringing in the artistic understanding. Those visual images are really amazing, plus that underground piece. That was I think one of the things that brought us together originally was some of my work on groundwater in Jordan and that interest for what's underneath us.
That's our secret sauce.
Yeah, exactly. Can you talk a little bit about where you draw inspiration and passion for your work?
I think for me, the best part of the work is seeing ideas that I get to work up, think up on my own, seeing them change people's understanding. And I like that with students. I like the moment when I see somebody have an aha, like they recognize what it is I'm talking about. And I see it with community people that I work with, that they have a moment where they see a demonstration or understand something from being in the field together. And then I see it with policy people and community groups. I've been hammering on the groundwater topic out here in California, and I finally see it being taken up by lots of other people, including the US Geological Survey and policy people. So I find that super satisfying when you think of an idea and then all of a sudden you see people start to pick it up. They don't give you credit for it necessarily, but that's not the point. The point is to give it away and then see people pick it up.
Yeah, I think of it as a little bit like planting seeds out there, where you have to plant the seeds and you're not necessarily the one who gets thanked for that, but those seeds are now out there, and that's the move forward.
Yeah, and I think that when I was trained, it was, we were looking at designers like they were some kind of heroes, McCargian, individuals who have to do something heroic. I'm not interested in that. I'm interested in seeing ideas appear in other people's words and other people's work that I may have had some part in sharing.
Great. So much of your current work centers around the idea of frameworks for design. Can you explain what you mean by the term frameworks and how you see it impacting the worlds of design and planning?
I have a slide about that.
Perfect.
Screen here. So I was trained at Harvard by this wonderful, brilliant person, Carl Steinitz, who had a kind of fascination with frameworks and heuristics. Heuristics are tools for self-teaching. And an example of that is a list. Like every time I do something, I might check a list to see if I'm covering all the bases. Or when you get LEED certification, the LEED checklist is sort of a heuristic. It makes you go through your project and ask yourself if you're doing everything you can. Carl was somebody who used flowcharts as his version of how to make a framework. And what I loved about his work, I mean, it seemed in some ways very idiosyncratic at the time, and later it developed into something that is part of a book that he published in 2012 on geodesign. And it got a little more regularized and something that was easier for everybody else to read. But what I liked most about the frameworks were that they were strategic. What I loved about Carl's this framework here, is that he asked us all to look at how a decision is going to be made about a planning process and work back from that, rather than start by saying, well, what data do we have that's available? What's the map that I want to make? Or what do I love about this landscape? No, if you want your plan to be adopted, go to the decision maker who's going to make the plan or decide about whether to accept the plan, and find out how they're going to make that decision. Is it going to be a committee that's voting? Is it going to be one autocrat who gets to decide? Is it going to be a scientific panel that has criteria? So go to how the decision is going to be made about whether or not to accept your advice, and then design everything to fit that. And at the same time, bring in the ideas that you think need to be brought into the system. So Steinitz's framework is a really good example to me of how to think about what it is that we do. It's not the design process diagram exactly. It's more strategic and in a way more open-ended, because you can think about how decisions are going to be made first and then work your way back through whatever your process is going to be, whether your design comes from a dream or whether it comes from a Ouija board or whether it comes from a group of people who sat around 2 o'clock in the morning and came up with a form. That isn't really important in this framework. What's important is thinking about whether the things you've shown in your maps and in your models and in your impact assessments, will they all matter to the decision maker? Will they cover the things the decision maker cares most about? So that's how I learned to think systematically through frameworks, and strategically, to think of design and planning as a chess game, looking 6, 7 moves ahead, instead of taking it one step at a time and then showing up at the end and saying, but why won't you do what I recommend? So I think it's really important. And then as I use frameworks, I tend to use it more as a typology. This is an early example of a typology I used where I was thinking about what is ecological design and trying to come up with examples of what are different ecological designs that deal with change over time. This one I probably started using in the late 90s. And then Daniela and I both applied a framework I developed more recently about what are the different kinds of infrastructure we could use for coastal adaptation. So it's gone through my whole career, this idea of frameworks, because I got attracted to it through the work of Carl Steinitz.
Excellent. That's great. Carl Steinitz actually he was here last year and has an ongoing relationship with our department, which is a further positive connection. And I know several students, I'm not seeing all of the names, but I know that there are students here who have been through his process and conducted an IGC project. So that's really great to see that ongoing connection.
Yeah, I think Carl plans to come back and be with you again at some point soon to study the whole state of Utah. Carl is not short of ambition.
Definitely not. He always has these big visions. It's really inspiring.
It is inspiring, and it reminds us all how to think at multiple scales. You know, his view right now is that we should all be talking at the national scale about meeting the UN Sustainable Development Goals and about carbon sequestration and climate adaptation. In some ways, he's right, but in the United States right now, it's hard to work at the national scale.
It's a challenging national scale to work at, for sure. I think the EU might be having more success at that big picture and parsing down to smaller scales than we do here.
I think they do, but then you can see they also have tensions with Brexit and other kinds of things. So everybody's struggling with, should the values that they use be what's good for us, or should the values be what's good for the larger group? And personally, I hope we'll all start to focus on what's good for the larger group.
Absolutely. Can you talk a little bit more about what are adaptation strategies, and tell us about some of the strategies that you yourself have helped to develop?
Yeah, let me come back to the slides for that, because pictures really help.
Yes. Somebody said they say 1,000 words.
That's right. So this is an example of one of my students on the left working with a community member on trying to understand how rising groundwater, how rising sea level is going to cause groundwater to rise on the inland side. And we used colored water to start talking about that in a model. That's one of the things that I'm most concerned about, because I'm interested in the underground and how things change. So I wanted to say a little bit about what groundwater is, and then talk about what it is that we're doing. This picture shows, you know, everybody has been a kid at the beach at some point in your life who digs a hole and sees the water that you come to in the sand. And that's an example of groundwater, the shallow kind of unconfined groundwater that comes from rain, mixing with seawater in this case, but flows towards the ocean in the coastal area. And it's that water that's closer to the sea that's going to rise as sea level rises. This is an example from a recent paper, well, now 7 years ago, looking at groundwater in Cape Cod and how the salinity varies over the cycles of the moon, which drive the tides. And you see different high tide levels in these different sections. And you can see red where this water is more salty. So the moon drives not only the level of the water, but how far inland salt water extends and how far inland the groundwater rises. So there's a fascinating relationship, again, across scales between the moon driving the tides and then the tides bringing salt water in and the groundwater coming up. It's really a fascinating dynamic process. It's almost like the land is breathing in and out, breathing in this water from the sea and then exhaling fresh water to the ocean. My colleagues at University of Hawaii have thought a lot about how they're going to study this question, and they are using diagrams like this to represent, as salt water rises, the level of the freshwater groundwater also rises. That's this lighter blue. And eventually it can even emerge at the surface. So they've been looking at Honolulu and trying to understand how sea level rise will eventually lead to emergent flooding on the surface, coming up through the ground in the city of Honolulu. No matter what we build at the edge, even if you build a seawall or a levee, that groundwater is eventually going to back up, because most of our coastal structures are really designed for events, like a particular storm surge with a hurricane. And then the event ends and the water level goes back down. But sea level rise won't be like that. As it rises, it's not going back down. It's going to be a new permanent equilibrium until it rises again. But it's only going up. So we'll have to adapt to new equilibrium levels of the sea, and that's new equilibrium levels of groundwater. So it's going to come up behind whatever structures we build at the coast. And I think this is an area where we need a lot more data. For example, in the Bay Area, this is an example of having to do a version of applied science myself, because no one else had done it. there was no map of the shallow depth to groundwater, not drinking water groundwater. They had maps of that, but groundwater at the surface that's not confined by aquicludes and other layers. So we used well data from around the region and made an interpolated surface of depth to the water table in the wet season. So this is like a worst case scenario, depth to the groundwater. And in the red, those are areas where the groundwater surface is within a meter, 3 feet, of the surface of the land. So if sea level rose 3 feet, not all of these areas, but some of these areas would be at risk of additional flooding. Let me say a little bit more about that. I made these cartoons to try to explain to people in the public what this means. So here in the dark blue is salt water, and it goes underground as well as occupying the void space above the ground. Here's a levee, a coastal marsh, coastal road with a sewer pipe, and then here's fresh groundwater in the lighter blue, and a dry creek bed, because this is California and it's a Mediterranean climate, and we have a lot of dry creek beds most of the year. And here's an example of a place where there was pollution in the soil, and it was capped over with asphalt or concrete, which is something we did typically in the 1980s and 90s to keep people from coming into contact with that contaminated soil and to keep the rain from moving the contamination out away from the original location. But as time goes by and sea level rises, first it's going to go into the pipes and infiltrate and take up the capacity of the pipes so that human waste there's no room for it in the pipe. And that means people's bathrooms back up, basements can fill with sewage. Sewage pipes may not function, and drainage for rainwater may also not function. We'll see that groundwater begin to intercept old contaminated soils and mobilize those contaminants. And we'll be right back in the 1980s where there was all kinds of stuff moving around in groundwater that caused cancer by moving into people's pipes and basements and into their homes. So we need to recover a lot of what we knew then, go back to focusing on that topic. And it'll begin to fill creek beds, even in the dry season. And after a while, those things will add up to new problems before we ever see flooding at the surface. We could see health problems, sewage system problems, spot flooding from drainage systems not working, new risks of liquefaction in places where earthquakes happen, like here, new foundation heaving, structural problems for bridges and individual buildings. And eventually, as the sea levels continue to rise, we could see emergence at the surface. And where topography is bowl-shaped, we'll see emergence much earlier. So that's been my focus, is try to understand what's going on with rising groundwater within about a mile of the coast. This is an example from New Zealand where there was a high tide, an extra high tide because of a low pressure system, and groundwater came up through the storm system and actually discharged, bubbled out into this street like a water fountain. And this woman came out when she saw the flooding on her street with a rake and tried to open the drain to let the water out, not realizing that the water is actually coming up from the drain. So our storm drainage systems are going to start to work in reverse. And obviously we're not ready for that. So we have a lot to rethink about green infrastructure and how all of this is going to affect our urban systems. So I've been working with people to come up with how to adapt to this, how to surf it. Because if this is a levee with maybe a tide gate along the river, a tributary coming out to the ocean here, there's no way to keep the groundwater from rising behind it. So instead, I'm thinking, why don't we allow that water to rise, not try to block it off, create artificial ponds connected by tide gates to this kind of tributary situation, and then put floating 2 to 3 story buildings into those ponds. Floating is a good thing, especially if you're in a region with earthquakes, because then you don't have foundations in mud. It's very expensive to make a decent foundation in really wet soils. So instead of spending all that money on those foundations, we were talking about in a competition, This was from the Resilient by Design Challenge in 2018, where I worked with CMG Landscape Architects and AECOM and David Baker Associates Architects and some other firms. We said, well, what if there's a whole kind of honeycomb, an armature, a new mosaic of artificial ponds and wetlands for habitat and for wave energy reduction. And we actually make new urban districts on those artificial ponds and replace some of what we have now. So the basic idea is to think about floating on artificial ponds, doing more conventional developments that are higher. These probably would actually have to be 10-story or more to justify the cost of the expensive foundations. But to do floating in the ponds, make it recreational space, and be ready both for additional flooding and for earthquake events. So that was the idea that we called a tidal city. And I'm going to see if I can show a video that has, I think, no sound, of how some students demonstrated what happens if you made canals in urban fabric to deal with rising groundwater. So they're showing on the ends of this model water being poured in over ice, because the ice caps are what's melting, and it's grounded ice that makes a difference. You see the little white lines rising that represent the depth of the water table, and on the right there's a canal, and on the left there's no canal. On the right, the water, there's a hole in the plexiglass of the model, and the water is running out the way that it would in a canal that has a light amount of pumping. On the left, there's no canal, so the water keeps rising and starts to flood the street, flood the basement of the building, and so on. So canals may be something we start to introduce into existing urban fabrics to allow people to live as long as possible where they already live, instead of replacing those areas with floating units. So that's another thought. And these are some images of what a floating area might look like with canals that also protect existing housing. This is in an area called East Oakland, the Coliseum neighborhood. And we were thinking there about how these transitions can happen over time, because the way that sea level rise is going to happen, it's a multi-generational adaptation process. You can't just do one thing and be good. We're going to have to adapt over multiple generations. And that's what this plan shows. It's drawn by a student of mine named Thomas McKay. He showed floating housing here and new wetlands, and then 50 years later, a second band of that, and 50 years later, making those back into wetlands, into baylands, by cutting more ponds and filling the old ponds. And it goes back to an old idea Rich Haig used to talk about in landscape architecture, where he said, the essence of landscape architecture is to dig hole, make mound. And that's a great thing to remember for coastal adaptation. If we can balance cut and fill, we can adapt to high water. It's a very old human idea. And that's, I think, something that we can all, look forward to seeing happen. Other people are already doing this. The Dutch have built artificial ponds near Rotterdam, where people live, in this case on pile foundations, not floating, in artificial ponds that are basically stormwater wet ponds. They hold stormwater and they provide people with a beautiful place to live. And then in Amsterdam, they're taking it another step farther and actually making floating districts. And that's what I think we can learn from and try to do at potentially even higher densities in cities like Oakland and San Francisco. So that's what I work on now, is how we can build these districts that are adapted at the urban district scale with a combination of floating and canals.
Great, thank you so much. I think that really brings the vision and understanding when you talk about adaptation. Generally, this helps to put it much more visually in front of us. Can you talk a little bit about how your concerns for biodiversity or environmental justice are part of these strategies?
Yeah, I came from an inner city neighborhood myself, and I didn't want to work on that. When I first started in landscape architecture, I didn't want to work on that. I wanted to be as far away from that as possible. So I worked on salmon habitat in Seattle, but I was aware of the importance of fairness issues and, of course, and equity, which is more than fairness, which is about responding to people's actual level of need. So eventually I came back to it. I worked on public housing and salmon habitat in Seattle, and then worked on it again in the South Bronx, and gradually got more comfortable saying, okay, I'm really working on an environment for people and for fish. And then it dawned on me when Hurricane Katrina happened in 2005, that when human lives are at stake, I am going to worry more about that. So I started to switch to try to figure out how could ecological design serve the needs of equity. I also very deeply felt the irony of everyone in Seattle working on trying to provide habitat for cold water fish in a warming world. It's going to be tough to have salmon south of Canada in a warming climate. So I started focusing on underlying processes, not habitat for a specific species, because the species are going to move, I hope. I mean, it's not going to be good for them to stay where they are now. So I think we have to actually assist that. Human-assisted migration is going to be really important. And reintroducing species that may not be native to a particular place is going to be a new important idea. So now I focus more on equity because I see the urgency of the need, and because I know that underlying processes can benefit human health and wellness, as well as whatever the species will be that can live in that place 25, 50, 100 years from now.
Yeah, absolutely. We were talking the other day in my class, the students were talking about time scale, and that species over 1,000 years will adapt, that they will adapt and figure it out, and that the natural systems will change, but there will still be natural systems here, and that focusing on the shorter time scale, human species are going to struggle with adaptation and figuring out how to support that and do that in a healthy and productive way, and a way that reduces conflict is incredibly important at this moment in time.
Yeah, I mean, we're really literally in an adapt or die situation, and so are the non-human species. If they can't adapt as quickly as they need to, they won't be around. So it's very sad. I mean, I worked for 20 years on trying to think about how to sustain the characteristic biodiversity of a region. And now I find myself saying, okay, I'm going to let that go. I'm going to focus on underlying processes that are going to serve some biodiversity, but not necessarily what we would think of as native or characteristic.
Yes, it's a hard thing to let go of the image of the pristine that you want to have there versus what is going to evolve and become what is there. Yeah. And that, you know, by focusing on ideas of connectivity and refuges, there's ways to provide for species at large, but not necessarily for any specific type or image of what should be there.
That's right. And it was hard for me because I had studied with Richard Foreman at Harvard, and we would look at the pre-development landscape and the developed landscape and try to imagine a hybrid that would support the species that were associated with the pre-development landscape. But now that pre-development landscape is not a possibility. I mean, you know, you can't take a city away. It wasn't really a possibility anyway, but we could mimic, we could use a kind of ecomimicry to make things work in some ways like the pre-development landscape. And now that's not a reasonable target because some of that landscape is going to be ocean, and some of it's going to be desert, and some of it's going to be go from forest to grassland. Look at California. I mean, we can't plant 1 trillion trees. We have to figure out how to take some trees away. So the world around us is changing, and it's adapt or die at this point.
Absolutely. Love to hear a little bit about your teaching approach, and if you can give us some information about the Super Studio. I know we're shifting gears, but wanted to get into some teaching stuff as well.
Yeah, I teach studios working with communities, which is tricky because you can make a lot of mistakes. I try to establish a good partnership with a community that can't afford professional help. And I try to support them in directing the attention of public agencies to what their needs are and kind of translating between the community and the public agencies. And in other cases, I've tried to partner with communities that are really developing their own voice And it's not a good time for us to partner because the role of the expert, it's not clear what that role is. And that's because communities are trying to develop confidence in speaking as experts themselves, community organizations and residents. So sometimes it's not good timing to work with a community, but I'm trying to figure out how to do that still and have some good partnerships now that I think students can learn a lot from. I think that by seeing scientific ideas, what's being published in the scientific literature, seeing international examples of adaptation, but then working locally with the real problems of real people, that's the best education. It keeps us from treating landscapes as flat, two-dimensional places, and it forces students to realize that these are real people that will want a particular outcome, and the artist's role is not clear either. Sometimes the role of the expert isn't clear, sometimes the role of the artist isn't clear, sometimes it really is more of a translation. And I hope that what's happening in my studios is that students are seeing this intersection of those 4 circles I started with, that Venn diagram, and thinking about the relationship between policy at the national, state, and city scale, and what it is we can accomplish together, and what the role of a professional is, which I think is to give our best advice all the time, not to sell a particular idea, not to necessarily have a vision that we want to sell to somebody, but to listen and adapt our own ideas as we work with people who live somewhere. It's one of the things we've had a lot of discussion about in my studios is this idea of placemaking, which people are pushing back against from communities of color and saying, wait a minute, you don't need to make our place. We will make our place. You need to help us keep our place and not allow us to be displaced, and help us to stay healthy and to prosper over time. So I hope people are seeing that in my studios, and with the Green New Deal Super Studio, we're talking a lot about jobs and businesses, how landscape architecture can translate into jobs and businesses for lots of small contractors, maintenance as well as construction, and then how we can create outdoor spaces for things like assembling precast, assembling solar panels, assembling green roof materials, and then having those become part of new building skins or new infrastructure. I don't work much on energy. I feel like that's not my area of expertise. I know that I'm glad a lot of other landscape architects are taking that on, but I work a lot on adaptation. And there's so much work to do for that. That's our version of the Green New Deal, is thinking about adaptation.
Yeah, I think adaptation has often been the forgotten second part of the climate change picture, and there's been so much focus for so long on the mitigation side, not to much great success, given that there hasn't actually been a reduction in carbon emissions, but there's a lot of fruitful ground in the adaptation space.
And that's somewhere where people from conservative political perspectives and progressive or left perspectives agree that there is extreme weather, there is flooding, there is fire. How do we adapt to that?
Yeah, absolutely. Definitely in my professional experience too, just talking about hazards versus, not versus, but sometimes the word climate can skew people in a certain direction, but the reality of the hazards that are being experienced on the ground day to day is not in question. Mm-hmm. So I have one final question for you, and then I definitely want to open it up to the audience, which is, what is your future vision for environmental planning? How do you see the profession adapting? Are there specific research questions that you see advancing?
Well, I wanted to share one quick thing while we have the slides up, which is an animation that just came out in a paper a few days ago. And I follow the literature all the time about what's happening with ice sheets in Antarctica and in Greenland, because that's going to affect cities. It's going to affect all the communities that I've worked with. So I want to show this little video for a second and hope that'll help. Let's see if this is playing. There it goes. So this video was made as part of a science paper and published as Science. And it's showing us the Pine Island ice sheet in Antarctica and the Thwaites ice sheet breaking apart, not just at the sea margin, but tears beginning to happen in that ice sheet by the grounding line, which is the place where the ice sheet meets the bedrock. And it doesn't look like that much when you're looking at this quickly, but it's so important to realize what's changing, that it's really changing, and that we sitting in San Francisco have to look at Antarctica to try to see our future. So I think that environmental planning in the United States focus too much on the environment of the United States. We try to improve our own water quality, improve our own air quality, improve our own biodiversity and habitat corridors. But what we did was we exported a lot of pollution generating work and industries to other countries. And that has come back to bite us because in fact, the whole globe is connected, and the pollution generated in the United States, in India, and in China is what's melting this ice. And when that ice melts, it's going to impact different cities in different ways, depending on how close or far you are from these ice sheets. So it's crazy how my undergraduate work in glacial geology has come back to be so important to me. But I think the future of environmental planning is to realize we're all on one planet. We are in one Zoom room, one. And everything is going to affect everything else. Not in the same way, but everything is going to affect everything else. So I think that understanding of global to local and local back to global in terms of flows and structures is something I wish more people were taught in landscape architecture and in environmental planning especially. And then I think this relationship between flows and armatures and the underground really is a critical area where landscape architecture can make a unique contribution, as opposed to what other fields are looking at, architecture and civil engineering. We can envision how it's going to affect coastal cities and how it's going to affect inland cities. I know the Great Lakes level are very high right now, and that's causing flooding and changes in groundwater around the Great Lakes. So to me, it's our special sauce. It's the flows, the underground, the armatures of landscape that we need to refocus on, but see ourselves as all one planet. Don't believe we can just clean up our own world and let someone else worry about theirs.
Yeah, I think that that's great. And I wanted to read one or two of the questions that came in from the students. So the first one is a really good segue. It says, what do you think is the strongest intervention point that landscape architecture has for adapting as the effects of climate change are becoming evident?
Well, shaping landform, that's the core thing that we learn, right? You take this class in grading and you think, well, it's about roads and pathways, but it's really the dig hole, make mound is the essence of what it is we can do. And in coastal areas, that's going to be absolutely critical as a way to think about surfing our new ocean level and all the implications that it has with storms and with groundwater and everything else. And then the other piece is vegetation. We learn about plants and the patterns of plants. We think about it sometimes at the scale of a single site, but we have to think about fire breaks and corridors that animals can use to move to suitable climates. So having vegetation add up in some way, either because you're taking away trees in a corridor where you want to stop a fire from spreading, or because you're planting trees or other plants where you want to create a corridor for animals to use for migration and dispersal. It comes back to plants and grading, but on a big scale. You really have to have a vision for how it interacts with geology and highways.
When you think about that scale and both the grading issues and the planting issues, how do you see speaking to decision makers, or how do you talk more about how that translation from the vision to the people at that decision point, when you think of Steinas's kind of the strategic point that he was making.
Yeah, I mean, it's a lot, sometimes it's language. I worked with Elizabeth Meyer at Virginia, and I really admire her intellect, and I learned a lot from her. But one of the things we talked about was how the word nature is so problematic. We don't really know what we mean when we say nature. Is that separate from people? Is that including people? But out here, when I'm talking to policymakers, I absolutely use that word. So we think about the mosaic. Something called the Operational Landscape Unit has been studied by a group of people out here at the San Francisco Estuary Institute. And they made a map of all of the operational landscape units, kind of like watersheds, but in a coastal environment, thinking about marine, littoral nearshore circulation as well as on the land. It's a fascinating piece of work, and they've created a resilience atlas that uses this kind of landscape ecological view of flows. But you can't tell elected officials about operational landscape units. They have like no time for that. So I started calling it nature's jurisdictions. And that's how you talk to people who think in terms of the competition between different jurisdictions, different counties, different cities. And that let them say, oh yeah, I know what that means. Nature's jurisdictions, not governments as we've established them, but spaces that have more in common because of the flows. So I think things like that are really useful for talking to policymakers and decision makers, but I also think it's, you have to draw their attention to the things that they don't focus on. And whether it's groundwater flooding or whether it's equity and communities that need more government support, more government investment, we can play a role in drawing their attention, drawing these agencies' attention to these needs or to new emerging issues like groundwater-based flooding. So you have to kind of be a pest. You have to not mind the fact that you're not working on what they necessarily think you should work on. You have to take them with you on a trip to look at some things that they otherwise might not.
Great. I'm reading through the questions here, looking for one more. And I think this one's a really good one to end on is, can you give some examples of those aha moments that you've experienced in your work and how those impacted your projects?
There have been so many. One was working with engineers in Seattle and thinking about how to do designs that would improve the quality of rainwater. And the science at the time was all about how, well, once a watershed is paved and urbanized, you know, if it's more than 10% paved, you just got to write it off. And I felt that that was wrong, but as we thought more and more about how to design stormwater and green infrastructure systems back in the very early days of doing this, we realized that design was the missing piece, that we could make a watershed that was 50% urbanized behave like a less developed watershed if we manage the water differently on the surface using green infrastructure, using rain gardens. So a very simple idea that design is an essential intermediary between science and policy. The science looks at what is, the policy looks at what could happen, but without design, the set of ideas for what could happen is too small. So design lets us imagine how things could happen differently. So that was a big moment where I realized I have to push back against scientists who think that the world is just the way it is. Design changes the world, for better and for worse. And maybe the other one is just this whole issue about rising groundwater. I think it's going to be so important. And because it's underground, people think it's not important, or because they can't see it. It doesn't matter until their electricity gets shut off by, you know, flooded electrical conduits underground. It's going to be a really big deal. And it was a huge insight for me because I had heard about the potential impacts of ice sheets melting when I was an undergraduate, and thought that wouldn't be part of my work in landscape architecture. But it's like a snake eating its tail, you know, it all connects. And we can see how, now I see how things I thought were remote issues in Antarctica are going to be everyday issues, bread and butter in New York City, San Francisco, Manila, everywhere.
Yeah, Florida as well.
Yeah.
And their groundwater and drinking water issues are highly correlated in that particular landscape.
Yep, and changes in the Great Salt Lake. I mean, in Utah, there are going to be huge impacts of climate change on evapotranspiration and evaporation rates, changes in the Great Lakes. So we're all going to feel it. And it's just a question of when we feel it and how that drying or wetting of the underground changes this little thin crust of city that we think of as stable is not going to be stable once it gets wet or super dry.
Yeah, absolutely. Well, thank you so much. It was really, really wonderful being able to have a conversation with you, have the students here all hear you. And I hope, I mean, we didn't touch on, but, wildfires and air quality is certainly something that has been on the forefront of my mind, thinking about all of my friends and colleagues in the Bay Area. So
yeah, it's impossible to describe what it's like to wake up in the morning and have the sun not come up. It's like living in a science fiction story or movie. It was 10:30 in the morning here and dark as a night outside. So I think people are being radicalized and energized to engage who are experiencing things like extreme storms or extreme smoke events, and the risk of loss of life with both also. But it's hard to understate how much our world is changing, and we're feeling it in California. Thanks for having me. I really appreciate the invitation.
And thanks for joining us. Danielle, back over to you. Do you have any final thoughts?
Thank you, Danielle and Kristina. And yeah, let's send all of our love and positive thoughts to any friends and family on the West Coast right now. Kristina, I want to give you just a really quick opportunity to give one more plug for the LAF Super Studio and the Green New Deal. How can students find out more or get involved?
There's a website, the LAF Super Studio. I don't know if you could look that up and then share it in the chat. Students can engage in teams with practitioners. They can go in teams themselves, and they can go in as part of a class if the whole class does it. And it's all year, so you can do it in the fall or you can do it in the spring. And I think it's going to be super exciting to see what we select from all of that to be part of the next Landscape Architecture Foundation Summit. So how it gets kind of curated and shared with people will be interesting, but the whole collection of things will also be interesting. And it's a very open call for ideas. So I hope people will feel free to explore adaptation, mitigation, whatever it is that you think is most important.
Great, thank you. I want to thank you again for joining us today. And before everyone signs off, just a reminder that next week we'll have Todd Johnson speaking with his colleague Mia Lair from Studio MLA. So please join us next week, Friday at 3:30. Thank you all for attending today and have a great night.